Okay, so those were the types of instruction writing frameworks. We now move to the type of instructions in terms of the function they perform. This again is something we looked at yesterday, so I will give a quick overview. Data transfer, arithmetic and logic instructions, program sequencing and flow of control, which decides the sequence in which instructions have to be executed, the jumping when you have an iteration or a conditional block and so on, and input output transfers. Now we come to the types of instructions based on how many operands we have. So for a long time now we've been studying types of instructions based on and the classification has been based on different criterion. So for one thing we studied direct addressing and indirect addressing yesterday, which is based on the addressing mode, based on that mode bit. And then we looked at types of instructions or types of instruction frameworks a little while back. We saw RTN, we saw assembly language, RISC and CISC. Then we looked at types of instructions based on the functions they perform: input, output, register transfer, program sequencing and so on. Now we look at again types of instructions based on how many operands are there. So you have 0 address, 1 address, 2 address and 3 address instructions. So 0 address instructions are instructions where we just give the command, the operation. We do not specify any operands at all. So how does the computer know where to perform this instruction? There is a set of registers in your CPU which function like a stack. A stack, I am sure you all know, is a first in first out linear data structure, meaning it can hold a series of values. Last in first out linear data structure, and again it can hold a series of values. So the last value which you put in will be the first value to be popped. That is how a stack works. So why am I talking about a stack here? You have a set of registers in your CPU which function like a stack, meaning they will take in a sequence or a series of values and store them, and the last value which was put inside them is the first value they will return whenever data is being accessed from them. So whenever I give something like a push or pop or even an add, some such instruction without any context, without any operand address, what happens is the data directly gets pushed into the stack. So for example, let us say I executed C equals A plus B. C equals A plus B is my high level code. I broke it down into sub instructions. I got the A and B values from main memory through MAR, MDR, all that. I sent it to the ALU. ALU has performed the addition and it has the result. Now if my next instruction is push, simply push without any address, any register, anything, then the ALU will send that value to this stack like register. So the value will get pushed automatically into that stack. So my point here being, in a 0 address instruction, you only give the operation or the command. You only tell the computer what to do. You do not tell it upon which operand to perform that operation or on which location that task has to be performed. The location is implicitly understood to be a general purpose register present inside your CPU, which acts like a stack. Next we move on to 1 address instructions. So as the name suggests, in 1 address instruction we have the command and 1 operand. So you give the address of 1 operand. The other one is implicitly assumed to be a special purpose register called the accumulator. So for 0 address instructions, we implicitly understood that the destination will always be your stack register, right? Similarly, for 1 address instructions, you have a specific register called the accumulator, which, as the name suggests, simply accumulates the value. So if, let us say, the accumulator currently holds the value 5, and then I push the value 10 into the accumulator, it will become 5 plus 10 equals 15. So it will just keep adding the values that are inserted into it and storing. So that's what the accumulator register does. And in a 1 address instruction, I will specify one address. I will specify my source operand, and the destination is always my accumulator. So if I say add m, where m is a memory address, the contents of the accumulator will be updated such that its current content plus the content of this location m. That is what a one address instruction is. So if I say subtract m, then your AC will become AC minus whatever number you had at m, and so on. So that was one address. And then 2 address and 3 address are fairly simple. In 2 address you specify 2 operands, both are source and one of them is also the destination operand. So if you saw here, here add a comma b, a and b are both source operands and b is also the destination operand. So that's what happens in 2 address instructions. So if you say add r1 comma r2, the contents of r1 and those of r2 are taken, they are added and then they are put back in r1. So both of these are source operands and one of them also acts as the destination operand. So which is that, the left hand side or the right hand side one, which also acts as the destination operand? That again depends on your system hardware and architecture. And finally we have 3 address instructions, which are the most clear, most easy to understand. You have 2 source operands and 1 destination operand. So that is classification of instructions on the basis of the number of operands they have. And these 2 slides are just examples of the different types.